So we're doing 8.6 systems of nonlinear equations. It's not always two nonlinear lines. It can be a nonlinear and a linear line. The thing on this lesson is that these can have more than one answer because this is a quadratic x squared plus 1 and this is a line. So if we have our parabola, the U shape, and a line, that line could cross it more than once. You're more than welcome to check all of these with Desmos and use it as a tool to help you graph it. Some of these you should be able to graph because we've finished 3.5 and 3.4, those parent ones and transformations out of the last chapter. But if you need to use Desmos, you're more than welcome to. So our first one is x squared plus 1. We're going to use the parabola, the quadratic tool. So since it's x squared plus 1, I know this graph is being shifted up 1. And then we're going to go up 1 over 1 because it is not being shifted. Oh man. I need to go to the... I gotta go to the computer. I can't graph this with my finger. Okay. Mouse. So it was x squared plus 1, so it's our parabola graph. That plus 1 means it was shifted up 1, so I shifted our vertex up 1. And then since it wasn't stretched anything, I know it's just going to be a 1 to 1, so 1, 1. Now we have to do our line, because this is y equals 2x plus 1. Since this is in slope-intercept form, I'm just going to go ahead and graph it using the intercept and slope. So my intercept, our b value, is 1. We did this in chapter 2. If this is super confusing, remember you can go to Desmos and check it out there as well. I did that really quick without talking about it. Okay, so my y-intercept was 1, so I graphed my y-intercept at 1. And then my slope was 2. So from my y-intercept, I went up 2 and right 1. If it was 2/3, I'd go over 3. So quick little refresher on that. Save, check my answer. Okay, then they're going to want to tell, they want me to tell them where the graphs intersect. So it's going to be this point right here and this point here. I can zoom in on my graph and check this just by graph. So I know both of them are at 0, 1 because I graphed that point on both of these graphs. And then my other point where they cross, it's going to be at 2, 5. And I'm just looking at my graph to find that. Let me go ahead and graph it on Desmos to show y'all. I keep saying it and I'm not doing it. Okay, y equals x, and to get the square, I do shift 6, and it gives me that little plus 1. Just be sure you click out of it if it's needed. And then we have y equals 2x plus 1. So I can zoom out or in so I can see it better. And we have our point 0, 1. Click on it so it shows. And then our other one was 2, 5. But just so y'all can see that. So you have 0, 1. And you're going to have to put these as ordered pairs, so x, y, with your parentheses and your commas. And then we have 2, 5. All the parentheses, all the commas, be sure you have the comma in between them as well. Graph each equation of the system, solve the system to find the points of intersection. Do they just have 3 options here? Okay. So I have y equals 2 square root of x. If you remember the square root graph, this is like half of a parabola, so this is not a square root graph. This is the reciprocal graph, so this is when it's 1 over x. They're all shifted a little bit, so they're not perfect, but this is the only one that resembles the square root graph. The others are all y equals 3 minus x, and I think they're the exact same. So this one, you can use our, I don't know why I can't remember if it's 3, 4. I think it's 3, 4 that we did our parent functions. Just all the graphs of is this x squared, the absolute value of x, square root of x. But on this one, you just needed to know which one is the square root graph. Okay, and then they want that graph intersects at, so we can pull this graph up. It only intersects at one spot because the square root is only in quadrant 1. And it intersects right there at 1, 2. You have to type it as an ordered pair, so parentheses 1, 2. X equals 6y and x equals y squared plus 4y. I thought I deleted this one because I don't like the y squared because this is not a function. And we just had our whole chapter over functions. So y'all haven't really learned how to graph these because it's turned on its side. So let's go here. X equals 6y. This one's not confusing, it's just sideways. And then our other one was x equals y squared plus 4y, or just 4? 4y, yep. It's not pretty. I don't even think you'll get one like this on the ACT. Okay, so they give us some points on this graph. There's our vertex and then 0, -4, and 0, 0. We're going to use those to graph it. So I'm telling y'all to use Desmos on this one because the other thing I want to do is delete it. But we're going to rock on with it right now. So our points were -4, -2. Then we're going to have 0, -4, and 0, 0. -4, -2. Should write it down. -4, -2. Then it was 0, -4, and 0, 0. And it just had us do 2. Okay. Now then we need our line at x equals 6y. So we're going to have a y-intercept of 0, 0 because we don't have a b. And it should be 1/6. 6. No. There. So I'm going to double check. X equals 6y. That did 12/2 is 6/1 also on here. Discount. Yep, 6/1's on here too. Okay. Good to go. We're going to go ahead and submit this one. I don't like this one because it's not a function and we focus a lot on functions for this one to be on here. I'm going to go use Desmos again to look at where these cross. And it has it on here. So 0, 0 and 12/2. 0, 0 and 12/2. We have to write it as ordered pairs. So 0, big finger, 0, 0, extra comma, and then 12/2. Next. X squared plus y squared equals 36. X squared subtract 6x plus y squared equals 0. I can do the top one really easy because we did circles briefly. And that 36, square root of 36 is 6. Now, if you don't want to complete the square to find this center, because I'm fairly certain on your test, you just have to say where they cross on these, or if it's x squared subtract 6x plus y squared. X squared subtract 6x. X squared, click over, subtract 6x. Plus y squared equals 0. Plus y squared equals 0. I have the graph not even. That's why it doesn't look like a circle. I'll fix it in a second. Okay, now let's see. How do I've zoomed on it earlier. Let's see, because my there we are. Okay, so to graph, I have them backwards. So don't. Can I swap them just for my sake? Okay. We need our center of this circle, which is going to be, we have 1, 2, 3, 4, 5, 6. Can I click on you? It's going to be right there at 1, 2, 3, 0. 3, 0. And then we're going to go out 3, right? Because you find your center when we're graphing these. And then it goes all the way to the other circle, so I should check. And then the only part where these two intersect is this point right here, because this one is inside of it. It's going to be at 6, 0. Next, y equals 3x plus 15, so that's a linear line. X squared plus y squared equals 145. That's a circle. So let's look at our ones down here. So the first thing I do is I check my circles to see if they're the same and where they all line up. I noticed that the scale on all of these is 13 and that they're all about hitting the 12-ish area, because 145, 144 would be 12 perfectly. So all of my circles are the same. Now then I have y equals 3x plus 15. So I'm finding the linear line that matches this. 3x is positive, so positive slopes go up. So it's neither of these, because these would both have a negative 3x. And then it's a positive 15, so that means my y-intercept is going to be in positive 15. So this one would be y equals 3x minus 15. So this is going to be our graph. And I found it using I guess deductive reasoning. I deducted the other ones because they weren't it. You can still use Desmos and check it that way. Then when we go to find our ordered pairs where these intersect at, I'm going to zoom in and I'm going to use this because I'm going blind. This is going to be negative 112. So I'm going to have, where do I want to write this? Negative 112. And this one is going to be, oops, 1, 2, 3, 4, 5, 6, 7, 8. Negative 8. And then I can't draw a straight line, but it's that one. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. If you put it in Desmos, it's going to pop up the points on it. So let's see if I can count. Or if I can see the lines. I had to start wearing glasses when I taught during COVID and had to stare at the graphs all the time on the computer. That was rough. Negative 112, parentheses and commas. Negative 8, did I put negative 9? Yeah, you can't really see it on that because it's in those words. Okay, let's see. Can I count? Heck yeah. Let's see what this last one is. We gotta graph it all. It's kind of the, is this the last one? No, 5 of 6. No, it's the last one. Okay. So x squared minus 1, that's gonna be our parabola, but it's going to be down 1, where our first one was up 1. And then you got to go both sides. So that's the graph of x squared subtract 1, because it was just shifted down 1. There's nothing in front of x squared, so it's just going to be up 1 over 1. If it was 2, you'd go up 2 over 1. If it was like 2/3, up 2 over 3, both ways. Our linear graph is y equals 4x minus 5. So it's in slope-intercept form, and I'm going to graph it that way. So negative 5 is my y-intercept, and then my slope is positive 4. So up 4, 1, 2, 3, 4, and over 1 from your y-intercept. Check answer. I think this one might have been hard to find the intercepts. I could show y'all algebraically how to do it. Let's do it. The other option is Desmos, so let's just go ahead and do this. I'm going to substitute 4x minus 5 into this y. So I'd have 4x minus 5 equals x squared, subtract 1. So when we have a quadratic, we have to get everything on the same side so that we can factor it. So I'm going to subtract my 4x, which doesn't combine with anything, but I'm going to add this 5 to this negative 1. So I'm going to have 0 equals x squared, subtract 4x plus 4. Then factors of 4 that add to get 4 is going to be 2 and 2. So I'm going to have x, and since this is a negative, they're both going to be negative 2. So 0 equals x minus 2. I'm not going to do it twice since they're the exact same. So x equals 2. Now, you'd plug it into either of those. So if I plugged it into the bottom one, 2 times 4 is 8, subtract 5 would give us 3. So, and just because it's easy and it's our last problem, I don't want to go. You have not completed. Are you sure you want to leave? No. So I do here 2 squared is 4. 4 subtract 1 is 3. It works on both of them. Our point is 2, 3. And you can check that on Desmos. Okay. Or you could eyeball it on this, but how many times do you get a guess? 3, 4. Okay. I feel like that wasn't the worst lessons we've done.